Okay, good morning. Continuing on the 10D notes, I want to talk about dilations and how, with similar figures, we could always sort of show that they're dilated. Okay, here's how. Let's say we take a triangle right here, triangle ABC. Let's say we dilate it. Okay, we talked about this in the previous video. So we're going to hit that, dilate from point, click on our triangle, put a point out here somewhere, and let's say we'll dilate it by a factor of 0.4. Okay. Now we have our new triangle, A prime, B prime, C prime. That's dilated by a factor of 0.4. So AB is 0.4 times as large as, this AB, and then AC prime is 0.4 times as large as that, et cetera, et cetera. We talked about that in the previous video. Okay. Also, here's what we got to know about dilations. If we take a line, all right, we go to the line thing up here, and we construct a line that goes through point A and through point A prime. You'll notice that that line also goes through D, which is our center of dilation. Okay. If we do B and B prime, okay, those also are going to go through our center of dilation. C and C prime, connect those. Those 2 points are also going to have a line that includes our center of dilation. Okay. So one way we know that shapes are dilated, ladies and gentlemen, is that we can draw a straight line through our original point and our dilated point, our original point, dilated point, original point, dilated point, and all three of those lines are going to converge at the center of dilation right there. Okay, so we're going to sort of do that and prove some rules about how triangles work. Okay, so let's begin. All right, and y'all are gonna have to sort of pay attention to this and really watch what I do, because some of these buttons can get a little screwy in ways that we look at this. Okay, so we're gonna clear the board, and I'm gonna go sort of in a different order right here. Okay, so let's talk about. We'll go in the order of the notes. So angle, right? So if we have two triangles where both angles, we have two pairs of angles that are congruent to each other, the triangles are going to be similar. So we're going to construct that right here. So what I'm going to do is I'm going to make a line, hit this line button. It's easier to do it this way, by the way, so make sure we're following along here. Okay. Next, I'm going to take a point. I'm going to put another point on this line, point C. Okay, put it right on the line. Okay. Now, let's say we want to make an angle at angle A that's 25 degrees. What we're going to do is we'll go down here to angle with given size. Click that button. It says select leg point, vertex, and enter side. So my leg point will be C. The vertex of my angle will be A. I want a 25-degree angle, so we'll hit 25. Okay. And now you'll see from A through C prime, okay, if we draw a line from A through C prime, it'll create a 25-degree angle right there. So we'll do that. So here's the line, A through C prime. Okay, we have a 25-degree angle. Okay, so I'm going to make another point up here, point D. Okay, and let's say I want to make an angle through point D. It's 100 degrees. So we'll go angle with given size. We'll hit C prime, D, and we will go with 100. Okay. So now our D creates an angle with our new point down here, C double prime. That's 100 degrees. Okay. Now I want to take this C double prime and move it if I can. I can. All right. So here we have a triangle with a 100-degree angle and a 25-degree angle. And we should know, ladies and gentlemen, that our last angle down here to be 55 degrees. Okay, because the angles of a triangle add up to 180 degrees. Okay. Now, if we just look at the side lines, we didn't even need to do that. We'll just do a dilation. Okay. So I'm going to come down here and we're going to make a new line. And we're going to make it parallel to this original line AB. How we're going to do that, we'll hit a point. Click it down here. There's point E. Okay, now we're going to do a parallel line. And we're going to click on point E. We're going to click on this line right here. And so on the bottom, it's going to create a parallel line through point E that's parallel to AB. Okay. All right. So now let's we'll make a new point down here, and we're going to do this again. Same angles. Okay. So there's point F, there's point E, and so now we'll make an angle with a given size. So we'll go F through E, and our first angle will be 25 degrees. Okay. So 25 degrees. We'll make a line through it right there. And let's make this thing a little bit smaller. So we'll put another point here, point G. Okay. And now we'll do our 100-degree angle. So angle with a given size, we'll go through point F, through point G, 100-degree angle down there. And we will connect those. Okay. We can move point H right on that line right there. Okay. Now, again, to prove that these two bad boys are dilated, okay, and if they're dilated, they're similar, all we'll do is we'll do lines through all of our corresponding points. So we can do a line from A through E. We'll do a line from D through G. We'll do a line from there, C through H. And we'll see they all meet at one point right there. Okay? And so I know this is kind of a little difficult to see, but this line right here that goes through these 2 points, this line that goes through these 2 points, and this line that goes through these 2 points all converge there. And we see our 2 triangles. Here's our original triangle. And all we did is we made a 25-degree angle and a 100-degree angle. Okay, and our other triangle here, all we did was make a 25-degree angle and a 100-degree angle. And the shapes were dilated, okay? And so that means these 2 shapes are similar to each other, okay? So take some time and try that out if you want to. And then I'm going to talk about the next one, which is side angle side, okay? Side angle side. So pause the video if you need to, and go back and rewatch it or do what you got to do. So next we're going to talk about side angle side. So we're not going to save that. Okay, so we're going to do another line here. Doesn't have to be totally flat. It could be like that. Okay. So AB. So what we're going to do is we're going to make a segment with a given length. And it'll go from point A. We'll say the length of this segment is going to be 5. All right. There's our segment AC. I'm going to move point C to where it's right on that line. Okay. So we have a segment with a length of 5. And again, we can measure by hitting this distance button here. Click point A, click point C, and voila, AC equals 5 will show up. Okay. So next, we're going to make an angle at point A, and let's make a 40-degree angle. So angle with a given size, C through A. Angle's 40 degrees. Now we can do a line from A through there. Okay. So AC is 5, and here we have another line segment here. And now let's do another segment with a given length, and let's do a segment with a length of 3. So segment with given length, we'll hit this button down here, click point A, and this segment will have a length of 3. All right, and we'll move point D to where it's along the triangle like that, or along this angle. And we'll measure it, distance or length from A to D. That's a length of 3. All right, so here we have a side length of 5, a side length of 3, and a 40-degree angle in the middle. And we can connect D and C to make a little triangle right there. All right, so that's step 1. Next step, we'll do another triangle down here. And first, we got to do a parallel line. So we'll make a point, make a parallel line. So it'll be point E, and it'll be parallel to that. Okay, so now let's say we want to make it similar, but cut the side lengths, in half. Okay, so let's say, these two side lengths, instead of 3 and 5, we cut them in half. And so now we'll have 1.5 and 2.5. Okay, so we'll make a segment with a given length at point E, length of 2.5. It'll be along there. Okay, we can measure it. EF equals 2.5. And we'll move F along this thing right here. Okay. Next, we got to make a 40-degree angle. So we'll make a 40-degree angle with given size right there. So go from F to E, 40 degrees. There we go. Make a line to connect those two. And now we'll do a new segment with a given length of 1.5. Okay, so we're just cutting this and this in half. So we'll do from point E, we'll do a segment of length 1.5. And that's going to be this segment EG right here. And so our distance of EG is 1.5. Use the move button to move that out of the way. All right, and then we'll do a line segment through GF. Okay, so here we have our original triangle where the two sides are 3 and 5, and I have a 40-degree angle in the middle. And here we have our smaller triangle where these two sides are proportional to these two sides because they're cut in half, and the angle in the middle is the same. Okay, and again, we could check to see if these triangles are dilated. Let's do lines through all of our corresponding points. So, if we go from C through F, and then A through E, and D through G, and you'll see all 3 of these lines that go through the corresponding points meet up there. That proves that those two triangles are dilated, and if the two triangles are dilated, again, same shape, different size, okay, which means they are similar to each other, okay? They're similar to each other. All right, hopefully we're good there. And the last one's a little tricky, but again, pause the video, stop it, rewind it, play around with it if you need to. Make sure you follow the directions closely. Maybe a good idea for you to watch a video on your phone and have on your laptop the app open here. But anyway, let's do the last one, which is side, side, side. So we have a triangle where the 3 sides are equally proportional to each other. So we'll do a line here. All right. And so we can do a segment with a given length. So let's do from point A, we'll do a length of 4. All right, so AC equals 4. All right, and we'll do another segment with a given length. Let's say from point A, we'll do a length of 4.5. All right, so that'll be that. We'll measure it. 4.5. do is we'll just do a segment from D through C. All right, and that has a length of 4.6. All right. So now let's say we're talking about side here. Okay, side. So we have three pairs of sides that are all equally proportional to each other. Then we will have two triangles that are similar and they'll be dilated. All right. So what we'll do is we'll make a new thing down here. So there will be a point E. We'll make a parallel line from point E to that. All right. Now let's double these. So we'll make a segment with a given length from point E. We'll make this one 8, which is double of 4, obviously. Okay. And next what we'll do is we'll do another segment with a given length, double 4.5, which is 9. This is where it kind of gets a little cool here. So that length has a length of 9. And now what we'll do is we'll do a segment from G to F. All right. So let's say we got something like that. And the segment length is 11.4. Well, we don't want this segment here to be 11.4. We need it to be double 4.6. Okay. So if we go to our calculator, not our calendar, our calculator, 4.6 times 2, we need our segment over there to be 9.2. So if we go to our move button here, we take point G and we move it, okay, to where our segment length is 9.2. Again, our 9 and our 8 should be set, okay? So all we can really move is our point G to make a 9.2. All right, so now here's our two triangles, okay? All the sides are equally proportional, okay? 8 is double 4, 9 is double of 4.5, 9.2 is double 4.6, okay? And now we'll draw lines through our corresponding points and see if they meet up in the same spot. So A to E, D through G, C through F. And what do you know? All three of those lines converge at one point right there, meaning that these two triangles, ADC and EGF, have been dilated. And if the triangles are dilated, they have been, or they are similar. Okay? So take some time, play around with that, watch the videos. Again, I recommend looking at it on your phone and doing the GeoGebra on your laptop or your Chromebook. It'd be good to have a mouse with you as well. That way it's easier to zoom in and out. And we will see you back in class. Have a good day.